Anisah Putri, and I would like to explain to you about Chapter 8, Euclid element. First, Euclid figure. In its development, Untitled mathematics gave birth to many mathematicians who have contributed greatly to the world of mathematics to this day. One of them was Euclid, the Greek geometer. Almost no one knows for sure whether Euclid was a credited mathematician or simply good at collecting and editing other people's work. It is possible that he attended Plato's academy in Athens, received mathematical training from Plato's students, and then came to Alexandria. There is some evidence that Euclid also founded a school and taught students while he was in Alexandria. Euclid is known as the father of geometry, the ancient mathematician who produced monumental work. The work is The Elements. The book became the famous human work and will always be used throughout the ages. Now, the element is contained in school textbook dealing with geometry and number theory. His position in history lies mainly in his great textbook on geometry called The Elements. The book consists of 13 book sections. The significance of the book's The Element doesn't lie in the statements of personal formulas it makes. Euclid's contribution lies in the way the materials and problems are arranged and their overall formulation in planning the preparation of the book. Most of the theorems appearing in The Element were not discovered by Euclid himself, but most of the theorems appearing in The Element were not discovered, but were the result of the work of the earlier Greek mathematicians such as Pythagoras, Hippocrates, Zeus, Thea, Athena, Eudoxus, Euclid, and etc. However, Euclid is usually famous for his logical arrangement of theorems, so as to be able to show, or admittedly not always with the precision demanded by modern mathematics, that they must follow from 5 simple axioms. Euclid is famous for designing a number of ingenious proofs, especially the theorems previously discovered. He was active as a teacher in Alexandria, Egypt around 3000 before Christ, but when he was born and died is completely unknown. What is clear is that he lived during the time of Ptolemy I, around 305 until 285 before Christ, who was the king of Egypt. The former papal general of Alexander the Great, Ptolemy I made Alexandria the capital. He also built the largest library in the world at the time. The library holds 700,000 scrolls of ancient manuscripts. Euclid was the first person in the world to establish a school of mathematics in Alexandria. According to Proclus, one day Ptolemy I wanted to learn geometry from Euclid. He invited Euclid to his palace and began listening to Euclid's geometry lesson. But then Ptolemy I found geometry was very difficult and too long to understand. So he asked that the lesson be accelerated. Euclid replied, "Even for the king, there is no shortcut to geometry." Nonetheless, in the field of geometry, Euclid left an important legacy for the world. So it is not wrong if Euclid is called the father of geometry. Here involved, most importantly, the selection of the arguments and calculation, for example, about the possibility of drawing a straight line between 2 points. After that, he carefully arranged the arguments so that they were easily understood by the people who followed him. Where necessary, he provides instruction on how to solve unsolved issues and develops experiments on missed problems. It should be noted that the book The Element is not only a development of the strict field of geometry, but also contains extensive sections on algebra and addition theory. Second, Euclid's books. In general, Europeans didn't think that Euclid's geometry was simply an abstract system. They really believe that Euclid's idea is really a reality. Euclid's influence on Isaac Newton is also very visible. Newton's The Principia is similar to the elements. In addition, various scientists are also trying to equate himself with Euclid. This is done by showing how all the conclusions logically derive from the original assumption. That is, among others, done by mathematicians such as Bertrand Russell, Alfred North Whitehead, and the philosopher Spinoza. The book consists of 13 volumes as follows. First, Volume 1. The contents start from axioms, definitions, and theorems of geometry. There are 48 geometrical theorems in this book. The first 26 propositions contain triangles, including proposition of two congruent triangles. Theorem 27 until 32 concern the parallels and the sum of the angles of a triangle. Theorem 33 until 48 concern parallelograms, right triangles, and square and their areas. Theorem 47 is about the Pythagorean Theorem, and Theorem 48 is about the inverse of the theorem. The next is Volume 2. Describe the relationship between rectangles and squares. Algebraic properties such as the distribution law, P plus Q multiplied by L is equal to PL plus QL, are explained geometrically. A rectangle whose length is P plus Q and breadth is L has an area P plus Q multiplied by L, and however, this rectangle consists of two rectangles. The first is length P and width L. So the area is PL, while the second is Q length and L width. So the area is QL. So the area of the rectangle is equal to PL plus QL. Therefore, it must be P plus Q multiplied by PL multiplied by L is equal to PL plus QL. There are algebraic transformations such as the computation of A multiplied by B plus C or A plus B square, and they provide solution to general quadratic equation. Pythagoras and his disciples are the main characters behind the Elements Volume 1 and 2. 3. Volume 3. In this book, there are propositions regarding circles, chords, tangents, and measuring angles. Volume 3 discusses the properties of circles. For the ancient Greeks, the circle was the most perfect flat shape. One of the properties of the circle discussed in Volume 3 is that the tangent to the circle at the point P will be perpendicular to the radius of circle OP. The next one is Volume 4. This book discusses geometry painting using Euclid's tool. With Euclid's tool, he draws triangles, pentagons, quads, hexagons, and regular 15s by dividing the arch of the circle, drawing regular end terms. A hexagon is created by first making a regular triangle and pentagon using a circle, with one of the parties coincidence P, using the fact that 2 divided by 5 minus 1 divided by 3 is equal to 1 divided by 15. The length of arch AB must be equal to 1 divided by 15 of the circumference of the circle. The mathematician responsible for Volume 3 and 4 was Hippocrates. The next one is Volume 5. This book contains the basic Euclid's theory of comparison regarding comparison made clear so that the theory of the discovery of irrational number by the Pythagorean school can be solved. The ratio of two similar quantities A and B, both the line segment, area, and so on, is the same as the ratio of the same magnitude C and D. If there are positive integers m and n, which are integers so that ma and b correspond to mc and d, or a divided by B is equal to C divided by D is equal to M divided by N. Euclid's theory was later developed by Dhea and Weierstrass. Volume 6. This book examines the concept of the similarity of two plane features, which was known by Pythagoras and his students. For example, two triangles are said to be similar if the ratio of the length of the corresponding sides is the same. Two similar triangles of the same size are said to be congruent, and furthermore, the similarity of two polygons can be checked by the similarity of the triangles that form them. This book also contains the form of similarity which is present perfectly and homogeneously. The next one is volume 7 until 9. This book discusses number theory, which contains a simple factual basis of Pythagorean number theory, which is now called Euclid's algorithm, which can be known by cross division to determine the GCF, largest growth factor, and KPK, least alliance multiple, or KPK and S.Pd. In this case, also add evidence regarding the uniqueness defined of factorization, summation of finite geometric series, and proof of the theory of existence on infinite prime numbers. Furthermore, it has been explained in the Pythagorean Theorem regarding odd and even numbers. In Book 9, found the postulates regarding the formation of perfect number, even number, such as 6 is equal to 1 plus 2 plus 3, or equal to the sum of the factors, and if Sn is equal to 2 the power of n minus 1 is a prime number, then 2 the power of n minus 1, Sn is a perfect number. Next one is volume 10. This book is based on previous studies on theatus. The study starts with a long research. It is very difficult to be able to see it entirely because it's in practical form and the ultimate goal of the type of irrational numbers. The next one is volume 11. This book contains some data involving the principle of duality, which applies to straight line and planes. Next is the most important theorem in trigonometry, and the last theorem is parallel surfaces. The next one is volume 12. This book is about calculating volume, followed by comparing a circle to the square of its diameter and a sphere to the curve of its diameter. Then the relationship between the tube and the perpendicular to the cone, all of which is proved in the adduction theory. But the most important thing is Euclid's success in determining the volume of the pyramid. The next one is the last volume, volume 13. This book is based on a study by Eudoxus that explores facts regarding the completions of general forms in geometric figures. What is important about Euclid's element is the paradigm it sets for the way that mathematicians should be studied and recorded. He began with some definitions and terminology and ideas for geometry, and then he noted 5 important postulates or axioms of geometry. A fraction of this postulate is first P1. Through each pair of different forms that cross the line. The next one is P2. For each pair of the segments, where is a unique point A on the line defined by A and B, so that A is between A and B, and segment AE with segment EB is congruent. P3. For every point C and each point A different from C, there is a circle with center C and radius CA. P4. All right angles are congruent. These are the 4 standard axioms that provide our conception of Euclidean geometry. The 5th axiom, the topic of intensive study for 2000 years, is a parallel postulate. The next one is P5. For every line for every one line and every point P that doesn't lie on 1, there are m unique lines through P such that m is parallel to 1. I think that's all that I can explain about chapter 8. Thank you for your attention and see you in the next chapter. Goodbye.